Welcome to this deep dive. Today, we're looking at a cosmic puzzle that scientists seem to have finally cracked.
Yeah, it's pretty exciting stuff. It involves these incredibly energetic jets coming from supermassive black holes.
Specifically from things called blazars, right? Like BL Lacertae. And the big question is how they produce these really intense X-rays.
Exactly. So a blazar, just quickly, it's an active galaxy powered by a supermassive black hole, basically eating nearby stuff.
And that whole process launches these jets.
Right. Super bright, super fast jets. And if one happens to be pointing, pretty much right at us here on Earth, we call it a blazar.
And BL Lacertae is a key one.
Oh, yeah. It's one of the first ones ever found. Actually, they first thought it was just a variable star back in the day, in the constellation Lacerta, hence the name.
Huh. So for ages, scientists have been asking, what's actually making the X-rays inside these jets?
Yeah, it's been a bit of a debate. The main candidates were electrons or protons.
And figuring out which one it is.
Yeah.
That tells you a lot about the physics in there.
Definitely. And it turns out how the X-ray light is polarized gives you a clue.
Polarization. Okay, so that's about the orientation of the light waves.
Precisely. If protons were the dominant source, maybe through interactions with magnetic fields or collisions, you'd expect, higher polarization.
But if it's electrons?
If it's electrons doing something called Compton scattering, basically kicking lower energy light up to X-ray energies, you'd expect less polarization.
Okay, and this is where the new tech comes in.
Exactly. NASA's IXPE satellite, that's the Imaging X-ray Polarimetry Explorer.
And its whole thing is measuring X-ray polarization.
That's its unique skill, yeah. It gives us this whole new perspective on X-ray light. And it wasn't working alone. It teamed up with ground-based radio and optical telescopes.
So they gathered all this data and...
No, it looks like we have the answer.
Which is?
Electrons. It really seems electrons are the primary source, doing that Compton scattering thing in BL Lacertae's jet.
Okay, let's unpack Compton scattering a bit more. You have these electrons.
Moving incredibly fast in the jet. Almost the speed of light.
And they hit, what, lower energy light.
Right. Think of them like tiny billiard balls hitting, say, infrared photons, which are lower energy than visible light.
And wham, they give them a huge energy boost.
Exactly. A massive kick, boosting them all the way up into the X-ray part of the spectrum.
And IXPE is the key instrument for confirming this.
It's the only satellite currently flying that can actually measure X-ray polarization like this. It launched back in December 2021. So relatively new, but already making huge discoveries.
It's amazing that BL Lacertae, this thing once mistaken for a star, is now, helping us figure this out.
It really is. So the specific observations we're talking about happened over 7 days, late November 2023.
Okay. IXPE staring at BL Lacertae.
Yeah. And at the same time, telescopes on the ground were measuring the polarization of its optical light and radio waves, trying to get the full picture.
And then something unexpected happened.
You could say that. Just by sheer coincidence, right when IXPE was looking, the optical polarization from BL Lacertae went through the roof.
How high?
It hit 47.5%, which is, just huge.
Wow.
Yeah, it's the highest optical polarization ever seen from any blazar in 30 years, a record breaker.
Okay, so the visible light is super polarized. You'd think the X-rays might be too, right, coming from the same jet?
That would be the logical assumption, wouldn't it? But nope, that's not what IXPE saw.
What did it see?
It found the X-rays were way, way less polarized. The measurement showed it was no more than 7.6%.
Whoa, okay, so 47.5% in optical, but less than 7.6% in X-rays at the same time.
Exactly. And that huge difference, that mismatch, is the smoking gun.
How so? What does that difference tell us?
Well, if protons were making the X-rays, you might expect the X-ray polarization to be high, maybe even track the optical. But this big drop
points away from protons.
Right. It strongly points towards electrons and Compton scattering. Like Stephen Ellert, the IXPE project scientist, put it, the fact that the optical polarization was so much higher can basically only be explained by Compton scattering.
So the difference in polarization nails it down to electrons boosting lower energy photons.
Pretty much, yeah. It's a really neat piece of detective work using light polarization.
And IXP itself, this mission.
Yeah.
It took a while to get going.
Oh, yeah. The idea was floated about 10 years back. Scientists like Enrico Costa were involved early on, and Martin Weisskopf really championed the proposal to NASA.
And it's delivering now.
Absolutely. This isn't its first big result either. IXPE keeps solving these long-standing puzzles about black holes, sometimes even challenging what we thought we knew. It just shows how important it is to develop new ways of looking at the universe.
So what does this finding mean for, our overall understanding of these jets?
Well, it gives us a much clearer picture of the physics happening inside. Knowing electrons are the main X-ray producers via Compton scattering helps us refine our models.
It confirms some theories.
It confirms a key part of how we think these jets accelerate particles and generate high-energy light. It firms up our grasp on the fundamental processes near these giant black holes.
Oh, what's next? Just look at more blazars.
That's the plan. Blazars are really dynamic, always changing. So the more we look, the more we learn. Who knows what surprises are waiting?
And this wasn't just NASA, right? It was a team effort.
Definitely. IXPE is a collaboration between NASA and the Italian Space Agency. Plus, scientists from, I think, 12 different countries are involved.
Wow.
Yeah, Marshall Space Flight Center leads it for NASA, but you've got BA Systems, University of Colorado.
Yeah.
It's a big international project.
A good example of science working together.
For sure. And that's really what IXPE is all about, providing this unique data on the high-energy universe. Opening this new window through polarization to see how things work in these extreme places.
Okay, so let's sum this up. For years, we wondered how blazar jets make X-rays.
Electrons or protons?
And now, thanks to IXPE measuring X-ray polarization, especially during this crazy high optical polarization event in BL Lacertae.
Right, that big difference between optical and X-ray polarization.
It points strongly to electrons using Compton scattering. Mystery kind of solved.
Seems like it, yeah. For this object, at this time, electrons look like the answer. It's a major step in understanding these cosmic powerhouses.
The real aha moment for you, listening, is that we're not just seeing X-rays anymore. We're figuring out the actual how they're made in one of the universe's most energetic spots.
Exactly. It connects the observation back to the fundamental physics.
And, thinking ahead, if blazars are so unpredictable, so dynamic, what else could IXPE find?
Right. What other assumptions might get overturned? What can we learn by watching how this polarization changes over time?
Does it tell us about the magnetic field, maybe? Or the structure inside the jet?
Potentially, yeah. There are definitely more secrets hidden in that polarized light. It's a really exciting time for X-ray astronomy.